So I mounted the SD Microelectronics sensor tile on this shield, which adds a USB port among other things. And I just need to power that up and run an Android app to start it talking. So if I plug in the device to a USB power, it starts flashing and I can connect. It found a device. And it's connecting. So it comes up displaying the temperature and barometric pressure. So it's 23 degrees, and if I heat it up with my finger, we can see that the temperature is going up, 26, 27, 28. It has a bunch of other sensors, of course, so we can select those here. This first one was the environmental sensors. There's MEMS fusion sensors. This is showing accelerometers. So as I rotate it, you can see that it rotates the die. It's quite responsive. What else can we do? We can plot data. So here it's just plotting pressure, which of course isn't changing. But we can also look at temperature, which we would have to heat up to make it change, and you can see it's going up in the range of 30 degrees and back down a bit as it cools off. We can go to look at the accelerometer and run it. So there are 3 traces, one for each of the axes. So if we rotate this, flip it over, we notice that the green trace has inverted, so it's -1G, and here the green trace is +1G. So if we go to this point, you can see that the blue trace is -1G. And if we do it this way, the blue trace goes to +1G. And if we want to do the red trace, we make red +1 here. And we make red -1 here. So the accelerometers, definitely, this is doing more than 1G, just flipping it around. Nice to have it showing up. It's all communicating via Bluetooth Low Energy. Let's have a look at what else we can do. We can do the gyroscope, which measures angular rate. So if I rotate it this way, it's got an angular rate. If I rotate it this way, it's got an angular rate in the another direction. And I think this way here gives us the blue trace. So there's 3 different axes of angular acceleration, or angular rate. Now we have the magnetometer, which also has 3 axes, and so as we rotate it, we can see that they change. And it's just picking up magnetic north in all 3 axes. Well, all 3 magnetometers are responding to the Earth's magnetic field there. This one is the microphone level. You can see as I talk, it goes up. If I stop talking, it goes down. Like that. So that mic is very sensitive. It's over there. And it's a lot further away than the mic you're listening to right now. So what else do we have? MEMS sensor fusion, whatever. So this is a lot of MEMS sensors combining. And we can actually break out into a compass function. So here we're looking for north. As we rotate, it tells us the direction of the device. And it will have a discontinuity when it switches at 360 degrees. See if I can find that right there. So right here is the angle where it flips over. So it goes from 360 degrees, 0 to 360 degrees, but then of course it has to go back to from 0 to 360 as you just flip over that divider. I'm not really describing that well, but if you rotate it continuously, it has to reset to 0 degrees suddenly. So that's a list of all the sensors that we're showing right here. So, and it can also do data logging and so on. So this app, I just downloaded it from the Android Play Store, and it just plugged in and worked immediately. And I wanted to demonstrate that before I start putting in some custom software. But ST Micro has done a lot of software for this device, and it's going to take some time to get the hang of all of that software and figure out how to integrate even more sensors from TE connectivity. We even have more items down here. There's cloud logging, which would allow you to use something like IBM Watson IoT to log data into the cloud. And there's one here to pick up the Bluetooth receive signal strength and the battery level. These things are quite close. The RSSI is minus 38 dB m, and battery not available because it's not running on a battery, it's running on a USB power. So it's a neat little app, but just one of the many things that you can do with this software from ST Micro.